the best path is selected by a routing protocol based on something called a metric. And usually what's going to happen is it's always going to pick the best route, the fastest route, the shortest route. And those routes are determined with mathematical computations or algorithms. Different routing protocols have different types of metrics. So the three that we will work with in the Cisco courses that you'll be taking is RIP, the Routing Information Protocol, and that just looks at hop count. And what is a hop? A hop is a router. So it looks at the number of routers. So let's say I'm at point A and I need to get to point B. It counts how many routers are in between A and B. That's the hop count. The other one is Open Shortest Path First, OSPF. It looks at the bandwidth from the source to the destination. Enhanced Interior Gateway Routing Protocol, EIGRP, that's the Cisco proprietary one. And it looks at a couple of different things: bandwidth, delay, load, and reliability. In 150, we just work with RIP. In 160 and 170, we'll be working with OSPF and EIGRP. So if a router has 2 or more paths to the same destination and they are equally good, then it will do load balancing. It will simply divide up the traffic so that everything can move along quicker. And that's one benefit of a dynamic routing protocol. Each routing protocol and each route within the table has an administrative distance. The administrative distance is basically a measurement of the trustworthiness of that route. And in this case, the lower the administrative distance, the better. Okay? So if the router has 2 or more paths to the same destination with equal cost metrics, then it will do equal cost load balancing, right? So let's take a look here and you'll see connected. So that means a directly connected network is got an administrative distance of 0. That's the best that you can possibly have. It's the lowest, okay? A static route, what that means is I have manually gone in and I've configured a route. I've said, if I'm at point A and I need to get to network 10.10.10.0, take this exact static route. That's going to have an administrative distance of 1. Again, a very, very good administrative distance. That means it's very trustworthy. An EIGRP summary route is a 5. We'll talk about that later. The other important ones here for us is internal EIGRP is 90, OSPF is 110, and RIP is 120. Okay, so we will be working with RIP. You notice it's the highest of the administrative distance, and it is one of the slower routing protocols. So the routing table is stored in RAM. We talked about that a little bit earlier. So it is volatile. So if you lose power to the device, you will lose what's in the routing table. So directly connected routes will be put into your routing table. And what's the administrative distance of a directly connected route? 0. Why is it so trustworthy? Well, the reason is because the router can see that it's attached to it. For example, R1, it can see that the network 192.168.10.0 is directly attached to it. It learns it by itself. It knows about it. Same goes with 192.168.11.0, 209.165.200.224. It's directly connected. It knows it's there. In the routing table, you'll see 2 different entries for directly connected routes. You'll see a C, which is the network address, and the L will be the router IP interface address, which we also know as what? The default gateway. Remote routes. So these are networks that are connected to other routers. These can be statically configured, something that you manually enter, or dynamically learned with RIP, EIGRP, or OSPF. So in this example, which we've looked at before, R1 will have 5 different entries in its routing table, 3 directly connected networks and 2 remote networks. So let's take a look then at the directly connected example for R1. Notice the C highlighted in yellow and the L highlighted in yellow. The C means that it is directly connected, and it's actually the network itself that's connected. L stands for link. Another name or another word used for interfaces is link. So this is simply saying the link address is 192.168.10.1, and it's link gigabit 00. So again, if we look right here, there's our gigabit 00, and that is our default gateway. Then if we look at another in orange, it's showing us the other directly connected routes. Now notice right up here, gateway of last resort is not set. What that means is if R1 receives a packet to an address that is not listed in its routing table, that packet will simply be dropped. So if we use this example, let's say PC2 is sending something to an IP address of 72.10.10.10. If you notice on this topology, there are no networks of a 72. Therefore, it will not be in its routing table. That packet will get dropped because a gateway of last resort has not been set. There's no route to help that packet get out. It will just get dropped.